All right, guys, today we're looking at lesson 5-9. And again, we're using those unit rates, but this time we're going to convert them with metric measurements. And I think that you are going to like the metric ones a lot more than the English system. They're very logical the way they set it up, and I sure wish that we could convert to that, but I don't know, United States may not make that happen. So let's fill out, we're going to start with our first example, metric units of capacity, and we're going to use this chart that's on page 321 to fill out. So you go ahead and fill this out. Notice we have ML, capital CL, DL, DAL. So everything is a liter, and so the liters are always going to be with a capital L. Okay, so go ahead and fill that out so that you have that for later. This is a good one for us to take a look at. Sam needs to fill a 5-liter water jug for his team. And if Sam uses the water bottle to fill the jug, how many times does he need to fill the water bottle to fill the jug? So we know that he's working in milliliters. And we want to see how many bottles it would take for 5 liters. So if we know that we have 5 liters, and we know that that would equal how many milliliters? What would we do? Yep, we would multiply it by 1,000. So that's nice and neat. So we know that it's 5,000 milliliters. And now we can say, okay, well, 5,000 milliliters is what we need. My bottle holds 250 milliliters. And so to solve that, look at, we can doot. So how many quarters would go in 500? It would actually be 20. So it would take 20 bottles to fill up that big one there. Okay, not so bad. So let's take a look and see if you can apply this idea for the focus on math practices. We want you to be precise. So now I want you to think of how many liters of water does Sam's water bottle hold when full? So knowing that he is 250 milliliters, I want you to convert that over so I know how many liters. So we know that it's going to be a part of it. So tell me what your answer is and explain to me how you got that answer. All right, guys, let's take a look at page 322, example number 1. This time we're going to use metric units of length. So we're going to fill out this middle table here, and you'll notice this time we're working in meters, and so everything is so nice and neat. Millimeters, centimeters, decimeters, but decameters, hectometers, and kilometers. The M is not capitalized. Okay, so liters it is, meters it is not. Not sure why, but you can fill out the chart so that you have it later from page 322. And then, so let's take a look at example number 1. Amelia is helping her father build a skate ramp, and they cut a board that's 1.2 meters long to use as the back of the ramp. Is the length of the board as shown in centimeters correct? Okay, so there's 2 different ways that we can do this. We know that 100 centimeters equals 1 meter, so we can say 100 centimeters per meter. And we know that it's 1.2 meters long, the board that they cut. And so they multiplied both sides by 1.2 to get 120 centimeters. I would have flip-flopped this, and this is just Miss Krumsick. 100 centimeters equals 1.2 meters, and only because I like to read things top to bottom. But we would be multiplying it by that rate of 1.2. And so, yes, they would have just enough board because it's 1.2 meters long. The other way you can see on this side of the paper is they set it up with 1.2 meters and they put it over the same unit rate, 100 centimeters per meter. They canceled out the meters, which I think is interesting, and then you can multiply that by 100. So either way, whichever one makes sense to you, you can do that. So for the try it, you need to go, the middle of the skate ramp is 2.5 meters wide. Amelia and her father want to use a board that's 23.5 decimeters long. Is this board wide enough for them to use? I want you to convert the decimeters to meters, and you need to explain. Okay, so I'm going to actually show you the answer on this one because I want you to be able to see it. So for this, we know that they have 23.5 decimeters, and we know that 1 meter is 10 decimeters long. And so I'm going to multiply I'm going to do this. I'm going to take away the DMs, and we're still going to divide by 10. So I'm going to divide by 10 and divide by 10. Well, look at that. It's so nice to be able to divide by 10 because then all we have to do is move the decimal place over. And so 2.3, I went the wrong direction. Nope, that's right. 2.35 is how many meters I have, and do I have enough board? Sorry, to do the 2.5 meter wide skate ramp? Nope, not big enough. Okay, so now I want you to convince me. How can you convert 2.5 meters to decimeters? So you're going meters to decimeters. So go up there, 10 decimeters equals 1 meter to determine whether the board is wide enough. So how can you convert that to know that you are on track? Will you put that in a short answer, please? Okay, we're going to do the last two metric units. We have units of capacity, and that should already be on your cheat sheet. And then metric units of mass, we're working in grams this time, and that will be the last one for you to fill out here to use throughout these problems. And I think we're going to do some more conversions in the next lesson, and then you're going to want to use that cheat sheet on your assessment that it will be coming up probably next week too. So I want you to be able to work through these. You can see the two different ways. I think that you will like conversions because you like to punch those numbers. Just pay attention to your conversion table and know which direction you're going. Are you going bigger? Are you going smaller? And then the same thing here. Look at those patterns, and I think you've got this. So we will do some practice, and then Friday, this is Friday's lesson, so please meet me at noon so we can do some of these to practice. And then I can check in and see how we're doing before we move on to next week.